Good morning to all. Today we discussed about that suspension, what is a colloidal solution, their properties and examples, and how we separate that some mixtures. So these are the topics we discussed today. And then previous classes we discussed about that what is a solution and how we concentration of solution and what the formulas. Okay. Now what is a suspension we discussed here? It is a heterogeneous mixture. Heterogeneous mixture is also called as a non-homogeneous mixture also. Okay, heterogeneous mixture in which the solute particles do not dissolve but remain suspended throughout the bulk of the medium, throughout the bulk of the medium. This is the definition of that suspension. It is a heterogeneous mixture in which the solute particles do not dissolve but remain suspended throughout the bulk of the medium. Say for example, that is muddy water, and that chalk powder which is dissolved in water. These are that examples of suspension. Say you take a beaker of water, in a beaker you fill a water and add some soil particles. We add some soil particles. This is the soil particles and this is the water. So and you stir it well. It dissolves it? No. So that is its suspension. It's suspended throughout the bulk of the medium. It's suspended. It does not dissolve completely. It forms two distinct layers. That is called as a heterogeneous mixtures. That is after 10-15 minutes. Don't disturb that this solution. What do you observe? That sand particles or soil particles are deposited at the under the beaker and water particles are upper side appear. The two distinct parts are appear. So that is called as a suspension. This is a soil particles and then this one is called as a water. That is called as a suspension. Now we go to the properties of suspension. Properties of suspension. The first property is it is a homogeneous. It is a heterogeneous mixture or non-homogeneous mixture. The second is the particles can be seen by naked eyes, by the naked eyes. Okay, the soil particles which can be seen with the naked eyes. So that's why it is a suspension. And then it scattered a beam of light. A beam of light while passing through it. Okay, so that if we pass that light through this solution, it scattered like this. It scattered means fell on it scattered a beam of light. That is called as a that is called as Tyndall effect. Already told in that Tyndall solution does not show that scattering beam of light, but it shows the scattering beam of light called as the Tyndall effect. And the third is it can be separated by filtration process. It can be separated by filtration process. You take another beaker, then you slowly without the disturbance, you slowly pour that water, and that bottom soil particles remain in the same beaker, and the water is pour into that next beaker. That's why like this, and then by the help of the filter paper we can separate it, this soil particles and water particles. Okay, that's that properties of suspension. Okay, next, another type of solution we go to, that is colloidal solution. Colloidal solution. What is a colloidal solution? It appears to be homogeneous, but it's actually heterogeneous mixture. Okay, it appears to be homogeneous, but actually it is a heterogeneous mixture. It is a heterogeneous mixture. Okay, so that it has two components. That colloidal solution also consists of two components, that's dispersion phase and dispersion medium. Okay, dispersion dispersed phase and dispersion medium. So what is a dispersed phase now? That solute like component or the dispersed particles in a colloidal form, colloid form, that is called as the dispersed phase. Like in a solution we take that two components, that is solute and then solvent. In the same process in colloidal solution also we take the two components, that is dispersed phase. It means that solute like component or the dispersed particles in a colloidal form called as the dispersed phase. And the second is dispersed medium. What is a dispersion medium? That is the component in which the dispersed phase is suspended. That is called as a dispersing medium. It means it takes as a large amount in this solution called as a dispersed medium. In the solution what we take, solute and then solvent take as a large amount and solute take as a small amount. As the same way that colloidal solution also has two components, the dispersed phase and dispersed medium. Dispersed phase we take a small amount, that is compound dispersed particles in the colloidal form, and then dispersed medium means we take a large amount, okay, which dissolves the dispersed phase in, or which Dispersed phase is suspended, that is called as a dispersed medium. Okay, this is the two components of colloidal solution. Now we go to that some examples. That is example of colloidal solution is example of colloidal solution are, say for example, fog, clouds, shaving cream, milk, foam. These are the some examples of colloidal solutions. So there are two components are the dispersed phase and dispersed medium. In the fog or in the clouds, which one is dispersion phase? That is, dispersion phase is liquid and dispersed medium is gas. Okay, in fog what is there? How is fog is formed? By the moisture and the mixture of gas, that is dispersed medium is gas and the dispersed phase is liquid. So combining of liquid and the gas, that's dispersed phase and dispersed medium, colloidal is forms. Which type of colloid is called? We called as a aerosol. That is called as a aerosol. And you learned these table which is in a textbook, that page number 18. So how is that? Some more examples are given, that is and shaving cream, milk, foam, and more type of colloidals are given in that table. You just see that textbook page number 18, the table number 2.1, table number 2.1. you see that, you can easily understand now. Okay, next we go to that properties of colloidal solution. Colloidal solution. It is also a type of heterogeneous mixture. Okay, it is also type of a heterogeneous mixture. The size of the particles are too small. The size of the particles are too small, which cannot be seen, by naked eyes. We cannot see that particles. Say for example, milk. We can see that what is present in the milk by our naked eyes, but so many components are present in the milk, like cream. Cream is present in that milk. Are you seeing by your naked eyes that cream? So we cannot see. If we boil that milk, then we can see that layer of that cream. Okay, so that's why that size of the particles are too small, which cannot be seen by naked eyes. This is the properties of colloidal solution. And then second is, they do not settle down. In the suspension, it can be settled down, like soil different layers and water is different layer, but here they do not settle down when left undisturbed. Okay, if you put that milk without undisturbed, that layers shows the different layers of cream and then milk. Without boiling that milk, no, it does not settle down. Okay, so it is a quite stable. So it is a quite stable. Okay, Next, third property is that it shows Tyndall effect. It shows Tyndall effect. The name of the scientist is also that Tyndall, so that he gives his name, that's Tyndall effect. Okay, this Tyndall effect means scattering of beam of light. It shows the scattering of beam of light. And then fourth is they cannot be separated from the mixture by filtration process. By filtration process. Okay, this is called as a colloidal solution, their properties and then components. See, we take in an example of a colloidal, we take in a glass milk, we take a glass of milk. If we, by the help of the torch, so if we pass that light through this milk, what it shows? It shows the scattering of beam of light like this. It scatters the beam of light, so that is called as a Tyndall effect. But the particles we not seen with the naked eyes, but is help to scatter that beam of light, that is Tyndall effect. In solution, the Tyndall effect does not show. In suspension also show the Tyndall effect, and then in colloidal solution is also show the Tyndall effect. Okay, this about that colloidal solution. From the next class we discussed about that separating the components of a mixtures. Okay, stop today now. Thank you.